So I figure a good use of our time then is to first do a review of object-oriented programming, just because so you can get two different flavors. You have Josh who taught it, and you have me who's going to teach it as well. So let's do that. So I'm going to change over to the desktop. I'm going to touch a file called OOP example.py, and let's open that thing up inside of VS Code. So there are two schools of thought when it comes to programming. One of them is people who like to use functional programming, so the things that we've been doing so far, which is just write a function, pass stuff into a function, and that's it. That is super, super quick, which is nice. But another way to write code is using what's called object orientation, where your particular object knows stuff about itself. So think about like the world as a bunch of objects. And imagine everything has a consciousness. So if I went up to this TV right over here in the corner, and I said, how large is your screen? The TV would be able to know stuff about itself and tell me I am 32 inches. Now, if I went up to Bobby, Bobby is an individual. Let's pretend he's an object for object-oriented programming. And Bobby has certain things that he knows about himself that we don't know. So there are things that you hold inside until it needs to be called. So Bobby, what's your favorite pizza topping? You know, that's a method that's within himself. So let's create a quick example. So choose your favorite animal. Tiger. Forgot how to do this. Only one second.
It's fine as you do.
Okay, that's fine. Okay, so we've got this class called Tiger. I'm just going to make it go with a cat for now. All right, so we've got a cat. What are some things that every cat, like let's pretend there's a cat factory. I know this is not how cats are actually made. But let's pretend there's a cat factory for a second. What are some things when you create a new cat, what are some things that you need to know about it right away?
Hair color.
Hair color. So we're going to create an initialize function. So hair color is something that if you were the master at the cat factory, you need the hair color and a breed perhaps. And let's say cat name. Obviously there are more things, but we're going to stick with that for now. So we've got a cat class. You can think of it as a giant factory that you're going to make many instances of this cat. So there is, let's say there's a factory of people or person. When I create new human beings, we are all instances of the class person. So when I create individual cats, they are instances of this class cat. I'm going to do self.hairColor equals hair color. Self.breed equals breed. And self.catName equals cat name. And this is how most classes start inside of Python. What's happening here is this class, cat, has a method called init, which initializes. So I'm creating a brand new instance of a cat. So let's say John's cat equals cat, and I'm going to pass in my cat was orange, it was a tabby, and the name was Mango. So these are things that every single cat has available to it. So we know that when we create a brand new cat, it has a hair color, a breed, and a cat name. Now, within this class cat, these are called instance variables. So whenever you see something with self dot in the front, it's an instance variable. That's different from a local variable. Let's do something. Tell me about yourself. If I have some variable equal to 1, 2, 3. This is what's called a local variable. A local variable only exists within the confines of when you declared it. So I've got some variable here on line 8, and outside of lines 7 and 8, some variable doesn't exist. But there are things about every single object that you need to repeat over and over again. Things like hair color and breed and cat name. For human beings, it's what's your first and last name, what's your date of birth. Those are things that you need to keep track of in your own head. So these are These are basically very important. These are important things of information that you need to keep track of. And this is something that you might use one time. When I put a self dot, I have access to self dot hair color, self dot breed, and self dot cat name in every method within the class. I cannot call some variable on line 6 because some variable only exists on line 9. But I can call self dot hair color, breed, and cat name here on line 8 because it has the self dot in the front. So I'm just going to do print f. My name is self dot cat name, and I am a self dot hair color, self dot breed. I am an orange tabby. So it's John's cat. Tell me about yourself, and I'm going to evoke it. So again, we've got a class called cat. I'm initializing it with some, like if I was creating a brand new cat from the cat factory, I know that every single cat has a different hair color, a different breed, and a different cat name. So I'm going to say those things I'm going to pass in as instance variables. So I'm setting self.hair color to hair color, and so on and so forth. Once I do self dot something, I can use it within other methods inside of this class. So I can call self.catName, self.hair color, and self.breed over here because I've declared it in the initialize. I've created a brand new cat down here on the bottom. John's cat equals an instance of cat, capital C. I'm passing in orange, which corresponds with hair color, tabby, which corresponds with breed, and mango, which corresponds with cat name. And then I'm saying, tell me about yourself. What do you expect is going to happen after line 12? Yep. So John's cat looks inside the cat class and defines the method tell me about yourself and executes this line code right over here. So when I run Python OOP example.py, it says, hi, my name is Mango and I am an orange cat. If I were to take this self dot out of here, I'm now expecting local variables called cat name, hair color, and breed. These are no longer instance variables. And if you hover over it, it's an undefined variable cat name. If I said cat name, something else, hair color equal to black, and breed is equal to something else again, if that error goes away because I've declared 3 local variables called cat name, hair color, and breed, and I'm calling it within this same method. Now, cat name, hair color, and breed only exist between the confines of line 7 through 11. Outside of this, these 3 variables are dead. They're just not alive. So let's try this one more time. My name is something else, and I am a black something else again. So let's go with Nick. What is the difference between a local and a instance variable?
Instance variable exists for that object.
Yep.
For that object.
Sure. Yes. Yep, that's exactly it. So local variables only live within the function that you declare them in. So cat hair color, and breed don't exist outside of line 7 through 11. Appending self to the front of it means that every method within this particular instance of cat knows about hair color, breed, and cat name. And if you think about this in a real life situation, for a human, let's pretend that we created a person class.
What's the command that you're using for that again?
Highlight the thing. If you know, once I highlight it, it will automatically highlight every other time that I've called it. And I only want the first 3 because I want to update all 3 of these at one time. So I'm going to double click, highlight it, Command D, and now I can do 3 cursors at once. So DOB, date of birth. So if we were to think about this in like a very real sense, let's say we have a class called person. Every single person when they're born is given a hopefully a first and last name, and they definitely have a date of birth. These are 3 things that every single person has. Now, self.first name and last name and date of birth, like you as a human being are able to do many things. Let's actually change this whole example back to person. There are some methods that you're able to do. You're able to tell me about yourself. You're able to run. What are some other examples of things? You're able to talk. So you as a person, when you were created, you're an instance of person. You were given a first name, last name, and date of birth. These 3 things are adjectives. Like you can think of this as like adjectives to a noun. Like these are attributes to this particular person. First name, last name, and date of birth. Those are things that you're probably going to need to keep track of over the course of your lifetime. You're also able to do things like my passport just expired, so I need to get a new one. So fill out passport stuff, right? I need to know things about myself. So luckily, an instance variable on me is first name, last name, and date of birth. So when I'm filling out the passport form and it says, give me your first name, last name, and date of birth, I don't need to pass in first name, last name, and date of birth. All I need to do is just look inside myself, and I know that I know my first name, my last name, and date of birth. So let's create a new person. So John equals person. Name is Jonathan. Last name is Young, and I'm born on February 17th. Okay. So I'm able to actually call, tell me about yourself, and I'm going to change a few of these things here. So I'm just going to do self first name, self last name, and I am born on self.dob. When I run this, my name is Jonathan Young. I'm born on February 17th. That one makes sense. I guess this makes sense to people so far.
Can you make in your init like a self dot description and then have it equal to tell me about myself? You don't use like you use parameters for your init.
Will this work?
Would that build description? So I know I can do that in JavaScript.
Sure. Let us find out. Yep. So what Christian was saying is there are things that there are things that you can pass in. First name, last name, date of birth. You have a kid, you're going to tell them what their first name, last name, and date of birth. That's always going to be there. There's also maybe something like a description that you can automatically default to. So if I do self.description equals self.tell me about yourself, it's going to say there's an instance variable called description on your person. The value of that is tell me about yourself. And the value of tell me about yourself is my name is blah, 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 and I am born on this day.
You just call it.
Yeah, I just got self.description, John.description down here. Let's create one more class because I don't think people are getting this. Class dog. Every single dog is initialized with a def underscore init itself. And let's say 3 things that every dog has when you create a new dog. Breed. Same thing. All right. So whenever I create a new dog, let's say dog. Who has a dog here? I don't know. Let's say Juan's dog. All right, dog, and then what is your dog's name? Rocky. What breed is your dog?
Lab.
Lab. Coat color? Brown. So Juan is going to create a new dog named Rocky. It's going to be a brown lab. I want to create these to be instance variables because I know I'm most likely going to need to keep track of these three things that I pass in. Creating an instance variable is not saying, like, this is a local variable. It only exists between lines 2 and whenever initialize is finished. But if I want to create a instance variable, I'm going to put self in the front, and I'm able to use it in different methods. So I'm just going to type through this real quick. Dog name equals. What are some things that all dogs can do? What else? Chew. Okay, and last one. Smell. Kind of true though, right? All right, so every single dog is initialized with a dog name, a breed, and a coat color. These three are called instance variables because we got the self dot in the front. I'm able to use these three instance variables within every single method. So if I were to, I don't know, I'm not sure how to use dog name, breed, or coat color in any of these things, but I could just as easily just throw in dog name, self dog name here. So I can use the dog's name inside of bark. I can put, I don't know, the coat color. This is weird. Self dot coat color inside of chew, and I can use whatever self dot breed inside of smell. So the ability to assign an instance variable is pretty powerful because you can use those variables over and over again. You can call them within methods in the same class. So I got Juan's dog here, and I'm going to tell Juan's dog to bark. I'm going to tell it to chew and to smell.
You can do that all in the same word.
I don't think so. All right, so I got Rocky and Whoop because when I call it to bark first, I'm interpolating the dog's name. Then I've got Chew, which is going to chewing on my owner's couch, and then the brown instance variable. And finally, the smell one is and then you throw in the breed as well, and in your function.
You're saying you can't change that shoe, that's no.
Let's try. I think it's going to be one huge string.
Yeah.
Nope. So none type has no. Oh, okay, because you're printing something. That's the screen. You're not returning something.
Oh, okay. Put the return me.
Yeah.
That's good.
Yes.
So is the init definition that, I mean, usually it looks like these are all on the same level,
Mhm.
and the same scope. It seems like effectively all the other functions are in the scope of init.
Okay. So init, bark, chew, and smell are all part of the class called dog. Now you'll notice that when I indent very specifically, all the defs are on the same like level playing field. If you go straight down like this, because they are all methods on this dog. Init is what's called a protected method. This is something, anytime you see a double underscore, they're called dunder methods. Those are going to be kind of built into that class from Python. Whenever I don't have a dunder in front or at the end, it's a method that I create for myself. In my case, I created bark, chew, and smell. To answer your question specifically, bark, chew, and smell are at the same level as init. It's not nested within init.
But you can use that bark, like you use self
Sure.
at the top.
Yeah, you could just do self.bark right away.
And then it would run every time you created.
Yep, exactly.
Or if you did.
So there's that Rocky Woof because I created a new dog, and it ran bark, and then I ran bark again. I'll get you.
So I like, do you have functions as part of your init?
Yes. Yeah. Yeah, you can have functions within. You can create a function within here. But
So
go around.
Two things. Destructors, I don't really know that yet. Will be using that, or is that just Python just garbage collected by itself?
Yeah, garbage collection.
And the class variables, when you go to class variables, I think some people are really curious about the ones declared inside the class.
Sure. All right, so this. So line 9, this is a local variable. Local variables have nothing in the front whatsoever. It's defined within a method like this, and it only exists, this particular one on line 9 only exists between lines 8 and 10. Once you get outside of lines 8 through 10, this is dead. This doesn't exist at all. Instance variables, you put the self in the front, and you're able to use it within the confines of this individual dog instance, because your dog has a different name, breed, and co-color than my dog. There's another concept called class variables, which I don't particularly like, and that is, I'm going to do, I don't know, force of gravity. So this is an example of a class variable. Class variables are defined at the very top of your Python class like this. It looks like a local variable, just kind of like line 11 right now. But since it's not nested within a method, it is a class variable. Every single instance of the dog class has access to force of gravity, and every single instance of the dog class can also alter force of gravity. If I wanted to add one to it for, like, I mean, there are certain dogs that when they jump, they just fall faster than other ones because they're fatter. So, I mean, I know that's not changing the force of gravity, but it seems like for that particular dog, it seems like the force of gravity is faster for the fat dog than for the skinny dog. So you might make a joke and say, like, Juan's dog is overweight, so I could do like Juan's dog dot force of gravity plus equals 5. But once I do that, I'm altering the class variable force of gravity for every dog. Once I do that, Nick's dog is going to have a force of gravity that's 14.8 rather than 9.8. And then if he adds 5 because he's got an even fatter dog, then somebody who has a Chihuahua is going to have a force of gravity of, what is it, 19.8. I'm going to go with 16 because I saw our hand first.
You said dunder, what is dunder?
So double underscore shortened is dunder. So I don't have to say double underscore over and over again. And double underscore methods like this, there's 2 underscores, 1, 2. In the front, the name of the method, and 2 underscores again. So those are dunder methods. These are the ones that are built into Python. So you don't need to like initialize, like this init function is going to, like they already know what to do when you have the init function.
So say you wanted every dog to have a value that doesn't change, like all dogs are going to have 4 legs. Hopefully.
Cool.
And then you wouldn't want to put that under like self dot number of legs and just say it has to be void. It's independent of the parameters you pass in, or
So this, yeah.
say you don't like class variables.
Yeah.
So would you still put like self dot? Prefer to put self dot number of legs?
I would. So this is where coding becomes a little bit more open-ended and a little bit more choose your own adventure, I would say. It's totally legitimate to create a class variable called number of legs equals 4. Every dog has four legs, or do they? That's where you have to make the decision. Most dogs have 4 legs, some dogs have 3. So you could make that an instance variable right off the top. Self.number of legs equals 4, or you can pass it in up here and you can do number of legs equals 4 to begin with, and then change this to number of legs. But you have to, whenever you create a class variable, it's becoming a little bit more, your code becomes more rigid. It's basically saying, are you sure that you want to keep number of legs equal to 4 for every single instance of dog? Because some dogs are born with deficient, there's billions of dogs, right? Some of them are going to have some genetic variation, and they might not have 4 legs; they might have 2. So that's your decision as you decide. You had a question a long time ago.
I think it was.
Okay.
I'm sure it's kind of low, and what we're looking, but is there any constants, like, constants? If you would, I mean, in Java or C, you would declare that as a constant, and you don't want it modified, but you do want it to exist or be true for all instances. Python doesn't have it.
You mean like how do I declare?
Constant.
How do I?
Yeah. Is that by just copying it, or is that just by interpretation?
Once you throw it into a capitalize, you can't change it. So let me verify that. That's how it works in Ruby. Let's just say gravity equals 9. And let's try gravity. Gravity equals 8. I guess you can't.
Yeah, see, that's why I'm so
let's say constant in Python. I think I'm teaching this on next Monday.
I think you can put global on it.
well,
I think it can be redeclared, but it can't be
altered.
altered.
By type?
Yeah. You can't change its type. Like just like as const, you can redeclare it. Can you redeclare it?
No, you can't modify the value.
But you can redeclare it. Modifying the value that's there is the same.
Yeah, you can, it's mutable because the rate is mutable, but as far as like its type, whatever you're verifying, you can't.
We'll get to that one on Monday. That's a little bit about object orientation. Are there other questions before I jump into today's thing?
Is inheritance?
I don't want you to worry about that yet. I just want people to get used to how do I. It is. We're going to cover that on Tuesday. Yeah. So object orientation. What do you need to initialize stuff with your class with? What are instance variables, and how do I use those instance variables inside of methods? All right. Let's talk about regular expression. All right. So let's go to onemainfinancial.com. And go to apply. So whenever you go to a form and you go to some place where you enter like an email address and you don't have the @ sign and you don't have a dot, they automatically say that's not a valid email address. But how did they figure that one out? Or when you enter a phone number and you enter a bunch of letters, some places don't even allow you to do that. So let's try that. So a zip code, we know every single zip code is going to be it's just going to be a number. But if I try if I type in 5 letters, it automatically blows up and says invalid format. Now, how does it do that? Any ideas?
As a formatting, you said this is the zip code, this is the date.
Yep. So this form underneath the hood, this is HTML. There's a validation that basically says you must enter in numbers. But how did they power that thing?
Most efficient would be right.
Yep, the most efficient one is something called regular expressions. So regular expressions is the ability to use patterns to match different character combinations. Every single language has their own implementation of this, but more or less it's the same. No, nothing? Okay. So it works like this. You go to a form like this, you want to enter a desired loan amount because this is a loan company, and you type in A, B, C, D. It blows up and it says, please enter a valid number. Please select your loan purpose. But the first one is please insert a valid number. So if I just do 1, 2, 3, 1, 2, 3, same thing again, it still says enter a valid number because this is not a number. Underneath the hood, there's HTML, but underneath the hood of that, there's Regex, which basically says, does the thing that you enter match the pattern that you're asking me to look for? So this is especially useful for things like, if you want just a number, like phone numbers or social security numbers. People suck when it comes to entering stuff in on a form. Phone numbers is the worst one in the world because some people enter their numbers as dashes. Some people have dots. Some people have parentheses and dashes. Some people who are the worst just type in all the numbers and then you have to parse it out yourself. But there are many ways that people enter a phone number. So what happens is, we're going to use this Ruby one, but JavaScript and Python are identical as well. this is a quick reference just to select certain things. So it's just pattern recognition. So if I said I wanted to find the number, I don't know, 312-555-6677, there's another way I can recognize it, 555-6677. Do the same thing again with a space in there. Some people like to do, oh no, dots. Some people like to do X's. So these are all valid phone numbers. But I just want to select the numbers out of here. I don't, when I save it into a database, I do not in any way want to keep track of these dashes or the parentheses or the X's or the dots. So taking a look at the quick reference down over here, how do I don't know, how do I get just the digits? I don't want any of the characters, I just want the digits.
You have like 0 through 9.
There's a 0 through 9 somewhere, but there's another one that might be a little bit faster. Oh, sorry. Make this a little. All right. So if I'm looking through here, like this is a quick reference of how to use regular expressions. It's basically a foreign language. There's no real way to get better at it except to practice. So I'm just looking. Oh, it looks like any digit. Cool. So if I just do \D as a regular expression, then I will get all the digits back. Let's find out. So this is my test string. My regular expression is \D, and all the matches come out the way that I want. I've selected every single number on there, and I've also ignored all of the, the dashes and the X's and the dots. That's cool. But what if I have 555? This is no longer a valid phone number. I just want the first 10 digits. Let's take a look. Any guesses? How do I just choose the first 10 digits of every single string? Brackets 10. Oh, it looks over. Exactly 3 of A. So if I do \D and I do 10, I've just got 10 digits. However, then I've lost everything over here. So what this is doing is saying, I'm looking for any 10 digits in succession. So I've selected the first one, but I've also got all these are also valid. No.
You also gotta tell people put words sometimes in front of the number.
Okay, even worse. Now my phone number is not valid at all.
You have to skip between those maybe.
You gotta skip in between them.
Yeah, so in between those expressions, skip all special characters or yeah.
Yeah. So this is the thought process that you have to take, and this is the thing that's plaguing all developers. It's like, how do I account for every single variation of a particular string? So we said, let's do 10 digits, okay? And the student was like, what if we add a 1 for the country code in the front? Then my phone number is not actually valid because there's no, I don't think 131 is an area code. I'm not sure, but I don't think 131 is an area code. Other thoughts? How do I get just the first 10 digits? How do I ignore the first 1?
Maybe you could do between 3 or 10 and 11. I'll sit down there.
Okay, between 10 and 11. So if I just do 10, 11 like this. All right, now I have the first 11 digits with the country code. That's fine. So that's one way to tackle it. But what about these down over here?
You definitely gotta skip special characters.
You have to skip special characters. So I'm ignoring special characters right now.
Oh, you are.
I'm just, I hear you. So I'm just trying to choose between 10 and 11 of a digit. These don't match up because there's no 10 or 11 digits in succession. What were you asking?
Yeah, you can do D 10 times.
You could do D 10 times. Why not? Okay. But then that's the same thing as doing D with 10.
D times 10.
I don't think it's times 10. This, what we've typed in \D 10 times. It's the same thing as doing it like that. Goes right in.
You can do
Search for all the boring special characters, but I forgot.
Yeah, that is the fun portion about your work today. One thing, the way that I would do this one is I would get the first 3 digits, followed by the next 3 digits, followed by next 4 digits. That could be one way of doing things. Oh, that doesn't actually work.
Because it reads, I think it reads the character and it stops.
Yeah, it looks for 3 characters, and then and it looks for 3 characters in 3 digits in succession, then another 3, then another 4.
Use the maybes, right?
Maybe, yeah.
So,
Maybe 0 or 1 more of A.
or the option character.
Yeah. So let's say, let me see. I'm gonna say any non-white space character, 0 or more of A. So I'm gonna say followed by 3 digits, followed by anything, followed by, please work. So this one kind of works. What I've done is I've said any non-white space character, so any non-space. If there's 0 more of that thing, followed by 3 numbers, followed by another single occurrence of any non-space character, and then another 3 digits, another 4. So I've gotten most of them, but I haven't gotten these over here because I haven't accounted for this space over here either.
You do, I think it's like any number of spaces with a star.
Any number of spaces with a star, 0 or more of A. 0 or 1, so 0 or more, so it looks like the \S with a star. So maybe I can replace all these with stars. Cool, same thing as before because I have a space right over here. So this is where the fun kind of comes in. I will say that regular expressions is a completely foreign language, to be honest. Like nobody will look at this and really understand what's going on. This is literally just pattern recognition. I'm just cross-referencing with the references down over here.
First one isn't true anymore.
First one's not true anymore, that's true. Yeah, because it's non-space characters. So you have to kind of figure that one out. Let's say that we wanted, let's say that I just wanted the digits from your social security number. So someone tell me your social security number.
555.
111 222 3333. All right, let's pretend for a second that we have every single time they're going to enter it like this: 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. How do I select just the numbers out of here?
Digits. Yeah, you get the first 3.
Yep.
And you ignore any non-digit next to it. And same thing, ignore any non-digit in the last 3.
All right, tell me what to type.
Was it A or D? D? Oh yeah. So D.
I'm done.
Oh wow.
Yeah,
That's awesome.
Yeah.
So yeah, and when I just say select any digit from the string, it's just going to select the digits and not the actual characters themselves. Now today's a little light on. It's hard to teach regular expressions because I could just go over every possible combination with you, or we could just jump into this over here. One thing I wanted to point out is we're going to do Regex 1. This is an online tutorial that's pretty useful. Using the patterns here on the right, this is, I mean, all of these here look identical to the Ruby expression one. We're going to go just one by one. How do I get, what's the pattern to match just a bunch of characters like this, using this here on the right? So what is the regular expression just to get a bunch of letters? That's one way of doing it. So it matches up with just the first one. So dot star is a valid one. You can just do A through Z thing. After just A through Z.
That's the first one.
Star. That's another way of doing it. \D. \D is for digits.
Oh, That's right.
Any non-digit character, \D, star. That also works. So this is, we're just going to kind of work through this one. So anything that's not a number could work, but I want to make this as restrictive as possible. So I want just the letters A through Z, and I want any occurrence of the letters A through Z. That looks pretty good. We can move on. How do I just get the 1, 2, 3? Yep.
So can I use, like, let's say I'm just searching for characters that are like A through G, let's say, for example.
Yeah.
Can I just do A through G as opposed to, instead of
Let's find out. So the question was, let's say like I just want the ABC over here. Can I just do A through C? Yep. You can give it a range as well. So you have to match just the you just want the digits out of here. So how do I just get the digits?
You could do the brackets and then 0 through 9.
Yeah. So you essentially what I'm trying to say is there's many ways to solve these problems. It's going to be on you to figure that one out. I've got 8 minutes. I do want to talk quickly about destructive versus non-destructive methods as well. These are things. Here, let's just bring this over real quick. If you are wondering what this is, what I have found is people who are successful in this program versus non-successful. So basically, they're trying to figure out some marketing stuff to target certain people. People who are super successful have these things in common, and the people who are not successful have this as commonalities. So the one thing I found, there are three kind of categories of people. The first one is, this is prior to enlisting in Platoon. So people who tinker with computers in their free time, high academic achievement, high job achievement, like those people are going to be fine. Then the people who are well-spoken with clear verbal and written communication, like, or if you want to develop that, those people are generally also pretty good. The one thing that is equal to everybody, these are the traits that I literally went through every single graduate and I found the things that are useful and that, stuck out about them. These are the things that they all did well. They make no excuses whatsoever. They learn things on their own if they don't understand. They ask a lot of questions. So you can bother me. I know it's intimidating, but you can bother me. They have that can-do attitude where it's, I don't get it right now, but I will figure it out. They have persistence, humility. They show up early, they leave late, they take advantage of resources. So these are all things that are like cliche, good people do these things. But these are the ones that I found consistently do poorly in the program. I need you to hold my hand at all times. It's broken immediately. I don't know what's going wrong. Did you read the error? Nope. I need you to hold my hand and do everything for me. Might not be the field for you. People complain a lot. Don't do that. If you want the program to be done your way, then create your own program. That's just
Hilarious.
And this one is a little bit dangerous because people who read a lot and believe what they read without experience, without asking other people. Well, I read this in an article one time. I was like, yeah, but that's someone's opinion. That could be right, it could be wrong. Argumentative, and the last two, luckily no one in this room is that, but there are a few people who just are mad at the world. Everyone's out to get them. So just if you're wondering why I closed that really fast. We're trying to create personas for marketing, but try to get these types of traits inside yourself. Let's take a look here. We want to talk quickly about destructive and non-destructive methods. So I'm going to open up example.py. All right, what's the difference between a destructive and a non-destructive method? Someone who's not you. Destructive versus non-destructive.
I think destructive method alters the whatever data set.
Yep, exactly. Yeah. So a destructive method changes the original structure, the original data structure, and a non-destructive doesn't change the original. So let's say that I have first name equals Jonathan, and if I do first name dot capitalize, what do you think is going to happen? Let's print this one first. We just jump to a Python interpreter actually. 2. So let's say first name equals John. If I do first name dot capitalize, first letter is capitalized, which is nice. But if I jump back to first name, it still stays the original. So this is capitalized as an example of a non-destructive method. The output is different, but it doesn't change the original. That's what it means to be non-destructive. A destructive method is like last name equals Young, and I do last name dot replace G with 1, 2, 3 typo. So if I type in last name again, oh wait, I guess this is not also an example of a non-destructive method. You could replace it, but it won't alter the original. So let's say that we have code platoon staff equals John, Rod, Josh. Let's just stick with those for now. If I want to append somebody, let's say I want to put Alicia in there, who you've met. CP staff is actually altered. So this is an example of a destructive method. I do change the original. So by appending Alicia to CP staff, it alters the original, thus it's a destructive method. So let's say we're going to add in one more person named Tom. So CP staff now has 5 people inside of it, but Tom sucks. So we're going to fire Tom. There's a destructive method called pop. And when I pop this person off, it alters the original again. So again, be careful of your choice of methods. Sometimes when you choose destructive methods, you will be altering the original data structure that you didn't expect to. As much as possible, I choose a non-destructive method. Things like capitalize instead of first name equals capital, like first name equals first name capitalize. I might create a copy of an array and append stuff rather than altering the original. But if you know what you're doing, you can go ahead and do the destructive method versus the non-destructive. Yeah.
Would you recommend appending and copying? Just from my understanding, Python makes a new list in doing so, or?
I would say as of right now, so I know where you're going with that one. So it's like memory allocation and just big O copying over the old stuff to the new one. Right now, don't worry about that. It's such a small thing, but as you get to very, very large data sets, that is something you do. So essentially what's happening underneath the hood here, to kind of explain, is like if I have CP staff with 3 names inside of it, what is happening is CP staff is pointing to a particular memory address in my computer, and it's only 3 things long right now. Once I add in another person, I'm actually, like, I've got no more room in memory, so I create a brand new one. And I'm copying all of the old 3 plus adding 1 at the end. Inside of other languages like Java and C++, you need to allocate the number of spaces ahead of time. So, and then once you get to the end of that allocation, you just double the amount of space again. But in Python, you don't need to allocate the number of indexes in your array right off the bat. It'll do it underneath it.
I have a question about the pop.
Yep.
So when you just put in pop, it took off Tom, and you left it empty in there. If I decide, let's say for example, Rod decides that he hates veterans and wants to work for someone else.
Okay.
Can you pop off Rod, or do you have to use the function?
Yeah. Yeah, yes, you can. Like, so pop removes the last one, shift removes the first one. And if you want to delete somebody in the middle, then you have to basically find them and set them equal to nothing.
Binary search.
You could, I mean, you could binary search it. I tried to delete Rod. Yeah, I don't know. Let's find out.
There's definitely
Python.
I think it's probably.
Is it removed?
It could be. I will translate some. Python is like, yeah, pop by index. A quicker way.
Yeah,
maybe?
it's removed. Yeah.
A quicker way, I think it's for I guess more easier to read. You know how you splice things? So you can go from 0 to whatever index he's in, right? But not include that index. and then plus that to the index after him, to, you know, the bracket notation we use when we index the index. And then you don't have to use a function call or a method call.
All right, so
But
let's.
if you do it that way, then would that index number still remain empty?
No, it's
Then
gone.
I'll take it off too?
Yeah.
So once you remove something from an array, I think they resize it, the whole thing. So,
Maybe not.
all right, so we've got 3 challenges for today. The first one is going to be Regex 1. It's kind of a tutorial. You can work through this one on your own. It gets extraordinarily frustrating towards the end, I will warn you, because it's really annoying. But again, regular expressions powers things like when you enter a phone number and you enter a bunch of letters, like it only allows you to enter numbers. And how do they do that? They use regular expressions, which is the act of pattern match, using like computer pattern matching to only select things that you want out of your string. So you're going to work through Regex 1. There's one called validate phone that I created. Hopefully the specs run the way that I expect them to. It took me a while to rewrite these, and I just rewrote it a week ago. So in the case that you find any issues, let me know so that I can fix it. But essentially, it's read through the specs. So it's like when you call has phone number with a legitimate phone number, you should get true. If you enter a bad phone number, you should get false. You're going to be writing all of these methods and trying to pass every test here. So I've pre-written all the tests, and you need to write the code to make it pass. Finally, we have stock picker, which is basically if you have a bunch of things of money, like stock prices throughout the day, what is the time that you should buy and sell for the highest amount of profit? So if I buy at index 1 and I sell at index 4, the maximum I would get is $12. And you're going to write that in both JavaScript and Python. So no object orientation today. We'll go into more detail tomorrow. Hopefully it'll sink in a little bit today, and we'll review it again tomorrow. But that is all I have. Are there any questions?
Paired or single?
We're going to do single on Monday, Wednesday, Friday, and pair on Tuesday, Thursday. Be a little